Hello, everybody. My name is Nathan Sodini, and welcome to Michigan Tech Racing Formula SAE Enterprise. This is our 2022 Design Expo presentation, and we're here to tell you a little bit about what we have to do. So a little bit of an overview is who are we? A couple of our interesting projects coming up for the 2023 model, as well as some 3D metal printing going on, a new hub dyno, as well as CVT tuning is on the horizon for us. So a lot of exciting big capstone projects going on the team. We always average about 8 per year. So pretty exciting stuff going on in our team. So a little bit of background about who we are and what we do. We are an enterprise here at Michigan Tech that is comprised of about 50 members. We have a wide range of majors from biomedical, business, mechanical, electrical, computer science, and everything in between. Our team has a very typical hierarchy structure with a president and a chief engineer up at the top. Then we have sub-team leaders. We have 5 sub-teams that our members are able to be a part of: business, chassis, composites, electrical, and powertrain. Each sub-team has their own responsibilities and roles that they have to conduct throughout the semester in order to get that car up and running by the end of the year for competition in May. Speaking about competition, we have a strong history of competing at the FSAE student at Michigan International Speedway each year. Happens in early May. We've been going for the past 28 years is how long we've been competing as a team. So pretty interesting that we've been one of the eldest teams around the block. Pretty exciting. Competition is a conglomerate of teams around the world. Over 140 teams fly their cars in from around the world to compete at MIS, and we have a strong history of performing well at competition. X23 Monocoque is our first project that we were undertaking this year. So the X23 refers to our vehicle that will go to competition in 2023, that spring. So this will be 2 years out from now, so pretty exciting. The hybrid monocoque is a conglomerate of carbon fiber and a steel chrome ollie space frame chassis. So in years past, we've done an all steel chassis that you can see down here on the left. So lots of weight, pretty heavy, steel's heavy. So now we're moving to more of a hybrid design with carbon fiber, as well as that rear end being still steel to maintain structural integrity. So what does this carbon fiber monocoque gain us? A lot of weight is going to be reduced moving to this. Also, an increase in torsional rigidity. Torsional rigidity is if you could take the chassis and rotate it like this. So it increases that, which means that the chassis is safer and more rigid for our members to drive. It's also being compiled through a molding process that is commonly found in carbon fiber laying up. The MDF molds are to produce the carbon fiber cockpit, the front half of the vehicle that you see in black in the bottom picture. The upper picture is what the actual mold looks like. So we are taking that to the Laguna and milling it all out to give us that shape and putting those boards all together to stack up to create that mold. These molds are about 7 feet long by about 2.5 feet tall. So very, very enormous. They weigh over 800 pounds each. So we're very interested to see how this is going to come out for us. This year was much more of a prototyping and a proving behind the validation of the monocoque, and this upcoming fall is going to be when we're going to start manufacturing it. To couple with the monocoque, we're also introducing a new aerodynamics package this year. So pretty exciting. Back in 2019 on the X19, we released our new aero package, also our first iteration of an aero package we have ever done on the vehicle. So it was pretty exciting to be able to evolve from that to where we are today. This new aero package has quite a few goals in mind. We are running validation on this through our software systems right now, but our goals are a 5% drag reduction, a 5% weight reduction, and a 5+ increase in downforce. And we're already seeing positive trends with all 3 of those so far through the software modeling. We've also designed a new optimized motor support wing profile. So if you could see on the bottom picture here, we have a little bit of a bump out in the rear end plates. And what that allows is for increased airflow, and it's going to improve the engine performance by getting it cooler air flowing through there. So we're very excited to see where this aero package takes us, as it is our most aggressive aero package by far none we have ever designed on the team, and probably the most efficient. So we're really looking forward to building this upcoming fall. We have been able to dabble into some new technologies here at Tech. The 3D metal printer has been a great asset for us that we've had 2 successful projects go through it. So the first one is our intake system. So the intake is what moves the air into the engine. So we printed this off of 17.4 pH stainless steel for strength and longevity of the part. So this is pretty unique to us in that we are now able to print stainless steel. It's a pretty crazy concept to wrap your mind around in that we are able to print metal. So our powertrain team lead and his team have taken this from a concept generation through design and through manufacturing into the 3D printer and print it out onto the blocks that you see. So those will then get cut off and you can see the final product down below. So we have put this together and tested it in our car and we're yielding great results so far. So we're very anxious and very excited to see how this performs at competition this year. So again, very thankful to the meme department for being able to use this new tool that we have, the 3D metal printer. We're really looking forward to using it more in the future. One of the exciting things is we got a hub dynamometer. This one is pretty unique in that we are getting help from the APS labs with this. So we're creating an adaptation for the FSAE cars as we are on a much smaller scale compared to that of a normal vehicle that you would be driving home tonight. So what we're looking for with this is we're looking for data collection. So where the rubber truly meets the road is where we're collecting data now, right at the hub. So we're looking for tunability of the vehicle based off of the data that we're collecting. We're getting accurate operational conditions as well as rundown and transient conditions, and also looking at our driveline assembly analysis. So we're able to pinpoint exactly where we're looking for problems, solve those problems, and see if we're doing better. So you can see the design process flowing through. The guys are in the middle of manufacturing this now. So we're pretty anxious to see this start up in the fall for us. This is another one of our 3D metal printing adventures is the upright optimization project. So this is pretty unique in that the uprights are a key component to the actual drivability of the vehicle. So what is an upright, you may be asking yourself? If you look at the picture in the center, it's the orange piece that holds 2 bearings, a hub, the brake caliper, the brake rotor, and also the wheel nut and the wheel. So this all then bolts together, and then this all connects to the vehicle via the control arm. So this is a key component as it sees a lot of different forces from a lot of different angles. So where are we going with this? So currently we run a 7075 aluminum upright that is milled out of a billet, a big rectangle block of aluminum, and they're great so far. However, with this 3D printing technology, we are able to optimize this design and print it out of a titanium alloy. So unsprung mass is safe. So this is an interesting concept that we have gained a great understanding over the last 3 years here on this team. So we have the control arm and the upright hanging off the control arm. So that creates a lot of weight out there. And if you know anything about driving, it's all about handling and how the car drives. So if we're able to reduce the weight out there, it's not going to bounce around as much, nor is it going to feel too heavy in the driver's hands through the steering wheel. So by lightening that load, we're able to improve our handling of the vehicle and therefore getting a couple more design points at competition. This is also 3 times stronger than the current version out of the aluminum billet. And then we use Fusion 360 for the optimization, which is where you get these funky looking designs over here on the right side of your screen. So pretty unique. And yes, it's still strong enough to support the vehicle. So don't be too worried there with that titanium. Our last project that we got going on right now is our CVT Tuning capstone. This is a continuously variable transmission that we run. So if those of you are familiar with a snowmobile or an ATV, a lot of these have these type of transmissions put into them. So what are we looking to gain out of this? We're looking to gain at how do we maximize our power through the torsional springs and the pre-tension settings between the secondary and the primary clutches in order to maximize the power that's going to those wheels through the drivetrain system. We're also going to be adjusting our secondary to maximize our shifting power as that's where that occurs. So it's going to be a pretty unique project to be able to take the engine RPMs and transform those into a great efficient engine moving into our wheels and onto the tires and onto the pavement to scoot our car forward. So we're looking forward to that, to see all the fruits that it will yield this fall. With that, we want to take the opportunity to thank you for listening to us with the Design Expo this year. If you have any questions, we're more than happy to talk to you. This is a big passion and a big hobby for all of us here at Formula. So if you have any questions, please let us know. Contact us at fsae@mtu.edu. And my name is Nathan Sodini. I'm a current business team member here on the team at Formula, and I'm more than happy to help you guys out. Thanks for listening.